Here's another example of how to compute a Laplace transform for a multipart function. And I'm going to do this one that has no 5's in it so that we can see the Laplace transform as a function of s without any confusion with any number 5's. So let's assume that f of t in this case has these three parts, that the function f of t is 2 between 0 and 3, with a jump discontinuity at 3 becomes 0 between 3 and 6, and then another jump discontinuity becomes e to the 4t for t greater than 6. So by definition, the Laplace transform then of this function little f of t is going to be capital F of s, which is the integral from 0 to infinity, e to the minus st little f of t dt. So we'll derive what the Laplace transform is directly from the definition of the Laplace transform. So we go back to the definition of the function and realize the function is defined differently from 0 to infinity. So from 0 to 3, that integral would be e to the minus st times whatever f is on that subinterval. Well, it's just 2. So we'll plug in a 2 here, integrate dt. Continuing along the real line, we know that the jump discontinuity from 3 to 6, the function takes on the value 0. So we'll have e to the minus st times 0 dt. And then finally, from 6 on to infinity, the function will be e to the 4t. So for the Laplace transform, the weight function e to the minus st will be multiplied by e to the 4t dt. So there we have it. Those are the three forms that we'll have for the Laplace transform. So again, you have those three integrals that you have to evaluate. And now let's just do that. Push this over. And so we'll do the first one. The first integral will just be nothing but we'll pull the 2 out and we'll integrate from 0 to 3 of e to the minus st dt. The second integral is very simple because the function is 0, the integral will be 0, so this will be just plus 0. And then finally, we'll write the other part as a limit, as in goes to infinity, because we're not going to integrate with the infinity sign at the top, so we're integrating from 6 to n, introducing this random variable n, but we're letting n go to infinity. And just using the property of exponents, we'll have e to the minus quantity parentheses s minus 4 t dt. Okay. So the Laplace transform turns out to be just integrating those two components. Let's go ahead and do the first one. So the first integral will just have the quantity 2. We need to go ahead and integrate that. We'll have negative 1/5, negative 1s. I almost did it myself. Negative 1 over s, because remember, that is an s there. There are no 5's here, so that's negative 1 over s. That'll be times e to the minus st, and we'll evaluate that at 3 and 0. Okay. Again, s is not t, so think of it as a constant when you're integrating. All right. So continuing on, looking at the other part of the integral, we'll have that'll be added to the limit as n goes to infinity of what? Let's go ahead and do that integration. Again, this is just a number here, s minus 4. Just think of that as a constant. So, and because the exponent's negative, we'll have to have negative 1 over quantity s minus 4. That'll be multiplied by e to the exponent s minus 4t. And then we'll have to evaluate that at n, and then evaluate it at 6. And of course, we're taking the limit of that as n goes to infinity. So, going ahead and plugging in the values of 3 and 0 in the first part, what we will get is negative 2 over s. It'll be e to the minus 3s power. And then we will be subtracting what we get when we plug in 0 into that. So we'll have negative 2 over s times e to the 0 power. Okay. And of course, that's going to be 1. Over on the other side, we will have plus limit as n goes to infinity of what? Plug in n into the expression for t we have here, and we're going to get the limit of negative 1 over s minus 4 times e to the minus s minus 4 power times n, because we just plug in for t. Then we're going to subtract what we get when we plug in 6 into that same expression. So we're going to get a minus 1 over s minus 4 quantity e to what power? Minus s minus 4 times 6. Again, there are no 5's here. Clearly that's going to be a plus, and we'll close the little curly Q there. And now we can clean this up a little bit. If we clean it up, the first part, realizing that what we really have here is 2 over s minus 2 over s times e to the minus 3s. And then what we have with the limit, we can see we've got plus the limit as n goes to infinity. Since that's going to be positive, we're going to have e to the negative, we could write it this way, 6 times s minus 4 over s minus 4 minus e to the negative n times s minus 4, just flipping the exponents around a bit, over the quantity s minus 4. Right? So we're almost done. What we can say to clean up the first part of the integral is we can maybe factor out a 2 minus 2 over s and make this 1 minus e to the minus 3s power. That's about all we can do there. And now what we can do is look at this limit. So to simplify this, this term would go to 0 only if we can guarantee, right, that s minus 4 is going to be positive. So that is n is obviously going to positive infinity. E to that negative power will eventually go to 0. So we automatically require s has got to be bigger than 4 for this Laplace transform to simplify. And it's just going to simplify to this term. So we'll have plus e to the minus 6 power times s minus 4 over the quantity s minus 4. And there you have it. That is the Laplace transform for that multipart function, provided that s is greater than 4. There are no 5's here. So hopefully this helps out a little bit. You just have to be careful. When you integrate with respect to t, you think of the s variable as a constant. Okay? But everything here is a function of s.